Okay, so now we're going to look at the ntfs file system, and you can have a look for that, and you could look up Wikipedia, and it's not a terribly friendly looking page, and there are a lot of complications in it, but in some ways it's not so bad either. There's the master file table, and this is actually fairly easy. We're going to have a look at it now and try to get a feeling for it. But once you have a good idea of what the master file table is, you've got the kind of the backbone of ntfs. Okay, so MFT, and this is a file, and it contains information about all the files on the system. Well, including itself, it's a file as well. Okay, and so that's what we're going to look at. So what I did was I created a RAM disk, and that's what I'm looking at here. And I attached this RAM disk to here, and I've actually set it to 0. So I'm going to change this convert to not able to convert. I think maybe I might have to start again. What happens if I format? Oh yeah, delete volume. Let's try delete volume. Yeah. Very good, okay. Oh yeah, and look, if I delete the volume, it changes some of this. Ooh, that's interesting. Bad. Very interesting. Okay, click yes. Okay, so it changes a lot of entries to bad. That would indicate, I imagine, that it had trouble writing to it, but because it's so regular, it seems a bit strange. Anyway, let's forget that for a moment. Actually, what I might do is I might go to one of these other windows and okay, so I can clear it again, and yeah, so now it's completely empty again. Okay, so let's go back to Windows and let's look at this disk. Oh, sorry, I have to go up here. And okay, so in disk management, I can change the, it says convert to a GPT disk. Okay, so let's do that. And this is just a partition. So there's this is this new partition type. When it says Microsoft reserved partition somewhere here, so it takes up a fair bit of space. Now let's just clear that again. Okay, so the watch window goes back to just one line. I've just emptied it. And let's go back here, and now we will choose, there's two partitioning schemes. There's MBR and GPT. Now MBR is nice and simple. It basically only uses a couple of lines here to set up its partition. Okay, and there is a simple partition. It's just got one partition in here. So now I want to format that, so let's format it. Once I format it, I'll have put on the ntfs file system. Okay, so I just keep clicking here. I'll change that name so we'll know it's different. Let's make it Charlie. Okay, and I'll perform a quick format. So once I click next and finish, it will start writing to this. And you can even see an ntfs here. This is significant because this whole disk only, the first, this part here is not used by ntfs. The partition actually starts down here. So you could work that out. It's 27 plus 1 and 1 and 1 is 3 and 2 is 5. So that makes 32 plus 4064. Okay, so too lazy to do all that, so I'll just go into Python, and I 32 plus 4064. Sorry. Yeah. 32 plus 4064, and that's the number of lines. So I multiply that by 16. Okay, so there's 27 there, there's 32 times 16 there, and 4064 times 16, which gives me this number of bytes. So that brings me to this address, XOX, paste that in, and you can see it's the same value. So if you move down this amount in decimal, you get to this amount here. So the ntfs partition starts here. Now, often we like to know what that is in units of 512. So we can take that divided by 512, and we get 128. Well, that's sort of what you'd expect, really. 10 in hex is obviously 16. Every time you move up, you get another 16. So this is going to be 16 squared, which is 256. So, and same with if you go up another one, you're going to get, that's that, and you can see this, the same thing. So 16 squared is 256. This thing here is obviously 16 to the power of 4 because it's you've shifted over 4 spaces in a base 16 system, so it's going to be that. So if you have this divided by, well, say this was divided by 256, it would be 256 again, because you've 16 squared divided by 16 to the 4, it would just be 16 squared, which is 256. So if you double that, you're going to have the number you get here. So that's why you get 128 there. Okay, so it starts off at an offset of 128. Okay, this is the ntfs partition, starts off at this offset of 128. Now you don't have to use, don't have to even do that mathematically, because you can use fdisk minus lu slash media slash ramdisk slash I call it usb.image. Okay, and that will tell me also it's the offset is 128. So now I can actually look at my partition using fls. So the offset is 128 that we just worked out. This is the file, so I can just see, oops, I need to put a space there. And it shows me these are system files in the root directory. So this is a completely empty partition, an ntfs partition that I've just created. And you can see these are the system files that are going to manage that partition. And in particular, you've got the MFT here. Okay, so that's what we've got. And the partition starts 128 sectors from the start of the disk. Okay, so yeah, it doesn't really show that there, but there's some unused space at the beginning. Okay, so that's that. Now, if I look at it in a hex window, there's another hex window there somewhere, and I think that's is it that one? Oh no, that's my watch window. So there's the other one here. That's the hex window. So let's quit out of that for a second and restart it. So let's have a look. So this is looking at the entire image. Oops. Oh, that's strange. Oh yeah, because so most of the when the partition was created, it only affected these. So most of it stay at the beginning stays at empty, 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 empty. Okay, so in fact what I'm going to do is I'm going to do that through the unique trick. Let's try unique minus F1 minus C and goes into less. Okay, so now you see there's 27 empties and there's gazillions of empties there, so we don't have to see them. And finally we get to our ntfs partition. So I'm just going to quickly flick through that. So you get something, obviously this all looks like garbage, but fairly early on you'll come across this, and this is almost certainly when the MFT contains information about the files, as I said, and they're sorted into records, and those records are exactly 1024 bytes long, and they all start with this file 0. Now just have a quick look. Do we have the Python window open? Oh, I don't. Okay, let's create a new Python window. Okay, so 1024. Well, 1024, you should know that's the same as 512 times 2, or 256 times 4. And 256, as we said, is 16 squared, which means it's going to be 100 hex. Okay, OX100 is 256. So 4 times 256 is going to be OX400. So every 400 in hex we'll have moved on 1 byte. So here we are at 1200. So at 12400 will be the next record. So let's say we move on to 12400, and oops, this is a bit early. Okay, there it is. There's our next record. So all the information. So each record usually corresponds to one file. Okay, and you can see the name about here, and the name of this file. Remember, this is Microsoft Unicode. So where is it exactly? Looks like this, 4D. The 24 must be the dollar symbol. Then the M is 4D, the F is 46, and the T is 54. So that's the name of this file. Okay, so it might seem strange that the file is referenced within the file itself, but it tells, well, the master file table, it's looked up for accessing every file. In fact, it's usually stored completely in memory. Now let's have a look. If you remember, we just had where had we had oh yeah, here's the sleuth kit. So we use the sleuth kit to access this, and we can see the MFT is entry number 0. This number here actually corresponds to the record number. Okay, so if you remember, we can use icat. Okay, so I can use icat to type a file directly from this bin. I just need the inode number, and the inode number is just in the MFT for the NTFS. It's just the index into it. So it's the record number, which is 0 for the MFT. Now this is going to be, I can do XXT again and pipe that into less. So now I'm just looking at only the MFT. Okay, so you can see there it starts off at file 0, and if you move down to get to 400, you get the next file, and that happens to be called MFT mirror. And just to remind you, if we quit out of this and we use FLS, you see entry number 1 is this, is what you'd expect. So entry number 3 you'd expect to be volume. So let's look at that again. So we want file, there's a second entry, and there's a third entry. Oh, this is actually called log file. Oh, sorry, that's entry number 2. Entry number 3 will be the volume. Okay, so if we go back to so you see really these files are FLS gets them. This program finds them by just simply looking up the MFT. 0 was the MFT. It for some reason sorts it alphabetically, which is a bit nonsensical. Second entry was MFT mirror, that's entry number 1. 2 was the log file. 3 was the volume, and so on. So if you want to understand NTFS, you simply have to understand the MFT, and the rest is mostly straightforward. Well, at least you'll have got the bulk of it once you understand that. Now, it's hard to get a feeling. Let's just type. We can use this ICAP method, and we can just pipe that into Word. WC minus C will count the bytes. Okay, so there's that many bytes. So get the length of it. Now remember, there's 1020. So let's say use Python again. Take that number and divide it by 1024. I'll just do 0.0 just to make sure it does it evenly. So you can see the current version, the current MFT on this system can handle 256 files. Okay. If it needs more, because it's a file, it can just expand. It can allow itself more space, just like a normal text file expands when it needs more space. Okay, it will just take up more area of the disk. But at the moment, it can handle 256 entries. Now, it can be quite hard to visualize this. But what's interesting is, if you imagine there was a picture, there'd be 1024 bytes across. And so you have a line of 1024 bytes, and then you'd have 256 of those. And there is, it turns out, a simple way to convert a binary file into a picture. And we would like to convert the MFT, just so we can visualize it, just have a look, into a picture. And it turns out to be surprisingly simple. If I take this, let's see, I did it there a while ago. Yeah. So I take this, so this basically just gives me record number 0 from this image, and this set command simply sticks this in front of it. It sticks P5, which means there's a format that says this is a picture. It's got a new line. It's got 1024 times 256. This is the size of it, and there are 255 values. It's just a simple grayscale picture. So if I do that, I create a file in the temporary directory called /mftpbm, and now I can just let's open that. Okay, so that's what the MFT would look like if we convert it to a picture. Now you can see it's about 1,000 bytes long. I'm not sure exactly where it ends, and there's 256 entries. Most of these entries are empty, so you can see all these here. If you remember, each one starts with FILE, and that is what those would look like. Okay, and you see something gradually starting black and gradually increasing. These are sequence numbers. The numbers are increasing, so that's what those are. And you can also see, so there's some entries there. Turns out I think that's about 16 entries, and then there's a few empty entries, non-used entries, and then some more entries here. Okay, and in fact that coincides with what you'd expect here. If you look at the FLS, you'll see that, for example, there's 0, 1, 2, 3, 4, 5 isn't shown, 6, 7 and 8, okay, and goes up to 10. In fact, you can't see them all there because we didn't do a recursive entry. Let's do a recursive entry, and now you'll see all the entries. And you see that there's a few numbers here that go a little bit higher, so it goes up to about 11, and then suddenly the entries jump up to 24, 25, 26, 27, 28, 30, etc. Okay, so there's a sort of a gap, and that's that gap that you are seeing here. Okay, so these are the first few entries, and there's a gap, and these are the system files. They generally they take up those entries, and the normal user files will start taking up these ones here. Okay, so I'm gonna stop there for a bit. I just want to give you a quick idea of how the MFT is run, and then we'll have a look at these entries as they're being modified.